All right, guys, 17.3 electric motors and generators. Regardless of what your interests are, I would imagine most of us are somewhat familiar with what these things actually do. So obviously I pulled up a picture here of a motor. We know, we use motors in our car to make our car go forward, but then think of other applications of that. Are there other applications, or you can even think of in your house that maybe you have some motors, maybe a drill, maybe your hair dryer, maybe things like that. So even though we might think of motors being specific to something like just, oh, it's something that's in my car, no, they are really found in a lot of things. The item on the right-hand side we might be a little less familiar with, so that's a generator. Maybe you have a cabin, maybe you got one of these out in the garage to help you with things. We know that item on the right, produces electricity for us. So in this section, we're going to be talking about essentially just overall what is a motor and what is a generator. And the things that we've already been talking about in the first two sections, so permanent magnets and electromagnets, are actually the reason why these things work. And it's kind of a nice lead-in to this. So we're going to learn how electric motor works. We're going to also learn about how generators work. All right, so electric motors, definition of an electric motor. So electric motors are essentially any device that converts electrical energy into mechanical energy. So think about that. You're taking electricity, electrical current, and you're having it do work for you. That's what mechanical energy is. You're having it move for you. So the book shows us this picture here. It kind of just starts off with this little simple picture. So imagine you have a disc, and on the disc you put a bunch of magnets around the outside of it. You'll notice they switched them. So the north and south are switched going all the way around. So now let's imagine we have this other magnet. You can see the hands coming in from the right-hand side there. You have this other magnet that's not attached. If you brought it near that disc, you know that if you bring it near there, it's going to attract the magnet on the disc, but it's actually going to repel the other one that's the same at the same time. So this attractive repulsive force will make the disc actually spin a little way around, just a little bit, right? Until it lines up with the south-south, right? Because then it's going to be attractive. So if you had the ability to take that magnet and then flip it, so to keep that magnet flipping, you would eventually be able to make that disc that's on there continue to spin. If you had the ability to just imagine, the ability to just rotate that magnet inside of your hand. So you can spin a disc by reversing magnets, and you utilize the attractive repulsive force of magnets. Not to get super complicated, but that disc that is spinning is what we call the rotor. So there's a rotating disc inside an electric motor or a generator, and we call that the rotor, and you can see why it's rotating. The rotating part of it, rotor, kind of makes sense. So the key to making the rotor spin smoothly is you got to get your magnet to reverse when the disc is at just the right place. So you want the reversal to happen just as each magnet in the rotor essentially passes by. So instead of having someone there with their hand and flipping back and forth, what a motor actually has is this device that's called a commutator. So a commutator is a device that switches the direction of an electrical current, in the electromagnet of an electric motor. So it does the work for you to flip it back and forth and flip it back and forth. So you can see in the picture here, they've just essentially created a very simple electromagnet, and then by reversing the current, you can reverse the poles, right? We've already learned that. So reversing the current, and then electromagnet will reverse the poles. And by you reversing the poles, you can get that rotor to spin based on the properties that we just previously talked about, using the attractive and repulsive forces of magnets to your advantage. So you can kind of see in the video there in the bottom there how this kind of works in essentially real time. So really, in all reality, there's really only three parts to any motor. And it doesn't matter if we're talking about really complex motors or really simple motors, but all motors contain these three main parts. So you're going to have a rotor, which is the rotating part with magnets that have alternating polarity. So the magnet's on there, and it's important that it's alternating, because if they're not alternating, you're not going to get that spin. You're not going to take advantage of that attractive repulsive force. So those fixed magnets on the rotor. And then you're going to have the commutator, which is that electromagnet switching the poles back and forth and back and forth and back and forth. So like I said, even though You know, we may look at a motor being something much more complex. Really, in all reality, those are really the only three big parts that you need. So the rotor, the magnets on the rotor, and then a commutator. Those three things will cause that disc to spin, and you're doing work for you, right? You're moving something, creating that mechanical work for you to get something to move. I mean, even think of something as simple as a fan blade. You know, you're wanting that to turn. So all you got to do is get that rotor spinning, and you're going to turn stuff for you and get some mechanical work done. So battery-powered electric motors. So here's kind of a simple one. I don't know if you guys have seen one of these before. They kind of took the end off on there so you can see it a little bit easier. Now, it's going to look a little bit different. You can see it does look a little bit different than the last picture. However, really the exact same three parts are still there. The three parts that I just mentioned, rotor, magnets on there, and the commutator. The difference just comes in is where those electromagnets and permanent magnets are arranged. So in the picture at the top, the permanent magnets surround the rotor and they stay fixed into place on the inside of the metal housing. So it's just how those are arranged. It's a little bit different. So the electromagnets in this motor are in the rotor and they actually turn. So it's not like in that last one where we saw it fixed on the outside. On the rotating part of the motor in this motor is called the armature. So this is the part that includes those electromagnetic coils that we just talked about. So the armature, the rotating part of the motor, including the electromagnetic coils. So just to give you a brief thing here, so how an AC motor works, and this is probably what we're most familiar with, the wires from each of these three coils are attached to the three metal plates, which are essentially the commutator at the end of the armature. As the rotor spins, the three plates come in contact with the positive and the negative brushes. You can see those in the picture there. They have it listed in the middle there. Electric current flows through the brushes into the coils, and as the motor turns, the plates rotate past the brushes, reversing the positive and negative connections to the coils. As you know, when you change the direction of the current through the coil, the electromagnets magnetic poles will switch positions. So the turning electromagnets with alternating poles then become attracted and repelled by the permanent magnets, and then the motor runs. So it's working off the same principles as we just talked about. It's just a little bit different of a setup. So yeah, we have a lot of AC motors in your house. So think of your vacuum, think of your refrigerator, fans, microwaves. So lots of motors are actually in your house. Generators. So that's a thing that we talked about earlier that is making electricity for us. So generators are devices that essentially do the exact opposite of what a motor does. So whereas a motor takes electrical energy and creates mechanical energy for us or turns it into mechanical energy, generators do the opposite. So they take mechanical energy and turn it into electrical energy. So motion into electricity, and they use the law of induction or electromagnetic induction. So electromagnetic induction, the process using a moving magnet to create an electric current. As you can see in the picture here, they're showing you what happens. Like, so when you move the magnet in, when you move it out on the picture there, you can see that the current is changing. If you just leave it inside there and you don't move the magnet, you're not going to create a current. So you need to move magnets in order to create electricity. It's just that reversal process that we've been talking about all along. So a moving or changing magnet induces an electrical current to flow in a circuit. So that's all it is. We've got to get magnets moving. If you can get magnets moving, you can create electricity. So it's really important to remember this sort of like reverse process here. So just as an electric current in a wire creates a magnetic field like we talked about, so electricity can create magnetism, this reverse is also true. So just by moving magnets, we can create electricity. It's a complete and total opposite flip of it. So a moving magnet induces electric current to flow in a circuit. So really in all reality, most physical laws display what we call symmetry. So it means that process works in both directions. So moving electric charges make magnetism, and magnetic fields can create electrical currents. So generating electricity, you're just getting magnets to move. That's all you're doing. You want to figure out a way to move magnets. This particular one that your book shows you on the picture here is actually an AC electrical generator, so it's producing alternating current. This is how generators that bring electricity to your house make electricity. You got to think about what we're talking about here. You need to move magnets. So how do you move magnets? So think about all of the ways that we can move magnets. If you attach them to a turbine, so think of like a blade, like you can see in the picture here. I just got to get that turbine to move. So how can I get that turbine to move? Maybe I can put wind in it. So think about a wind turbine, wind blades. What if I'm burning something? So if I burn something like coal and I produce a fire, I can use that fire to heat water, and water creates steam. Think of like a tea kettle with the lid on the top, steam, it starts bouncing around, right? So if I burn coal, I can create steam, which can turn a turbine. I can burn wood, which can, same thing again, heat water, create steam, turn a turbine. Water power, think of a dam. So if I take moving water and move it over turbine blades, I can get that happening. So that's all generators do. You want to move magnets to essentially create electricity. It really honestly is that simple. So motors and generators really are just complete opposite of each other.